grade 7. Now time for another Flip Classroom video. Today's topic is forces and failure. If you think about everyday examples, it is not too hard to believe that a small force can cause a whole structure to break and collapse. You rip solid metal open every time you crack that can of Dr. Pepper with the pull tab. You yank nails out of wood by using a claw hammer. Now today we will be reading about forces which cause structures to fail. Sorry. And how these forces can be used to make more effective everyday products. Yay! Pull tabs, wrenches, and crowbars are all examples of levers, or levers if you prefer. Drama. I'll be saying lever. A lever is a rigid bar that can pivot around a balance point or fulcrum. The place where you apply your own strength is called the input force, and the place where the lever does the work is called the output force. In the example of the pop can, the top part of the tab where you pull is the input force, and the fulcrum is the metal underneath the bottom part of the can, and the place where the whole drink appears is the output force. Look at the drawing below. Can you identify the fulcrum? You said right here. Ding, 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 ding. You're correct. Now, let's take a look at the levers on the next page. Can we find the input force, the output force, and the fulcrum? Let's check it out, shall we, grade 7? Here is example A. That's a Canadian A. B. And C. What do you think, grade 7? Can we identify input, output, and fulcrum? Let's take a look. I suspect ding, 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 fulcrum, output, input. That's a seesaw. How about a wheelbarrow? Can you identify the fulcrum? Ding, 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 ding. Now, which one do you think is the input? Is this the input? Or is that the input? I wonder. Ding, 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 ding. There's your input. So this must be the output. All right. It's baseball season. Wish those Jays would start winning again. Can we identify the fulcrum? Ding, 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 ding. Followed by the input force, that's the individual, and the output force, the work that's done. That's one way of looking at it, grade 7. Okay? Input is what you put into it. Weight going down, weight lifting, swinging it. Okay? That's your force. I'm using weight, I should be saying force, right? So the force that you put into it provides your input force. Output force, carrying rocks, swinging the baseball bat to hit the ball. Okay, remember, input, output, fulcrum. There are several ways in which materials can fail. Tension forces can stretch materials and cause them to snap. There are two types of tension forces. Shear failure happens when a metal is compressed and a section of the metal slides. The Tower of Pisa is an example of shear failure. Buckle failure is caused when pressure is placed on both ends of the material, crushing the pop can. This is an example of buckle. So let's remember buckle failure and shear failure. Torsion forces can also cause a material to fail. Torsion happens when flexible structures, such as electrical cords, folded and twisted into tangles and knots. Metal fatigue. Sounds like a band name from the 1980s. Metal fatigue is a serious problem which, in the past, has led to many disasters involving trains and aircraft. Over time, metal loses its strength due to it being twisted or bent for different purposes. When weakened, metal structure can develop cracks, which lead to the entire structure falling apart or collapsing. Inspections are so important. Despite the seriousness of the forces which cause structures to fail, scientists have also found ways to make good use of buckling, shearing, and twisting forces. Today, car bumpers are made to buckle in a collision, thereby lessening the seriousness of injuries to passengers. A boat's outdoor motor is designed so that if the propeller becomes tangled in weeds, a shear pin will break, allowing the motor and gears to continue to spin freely. Spinning wheels and other devices use controlled twisting to turn hair into braids, strong into durable ropes, and wires into resilient cables. All right, time for some review. What type of force or failure does each situation represent? Twisting sponge is an example of torsion force. An old rusty bicycle chain is an example of metal fatigue. What? The force placed on a pair of scissors is a shear force. Cracks in the pavement are an example of what kind of failure? Buckle failure. A plastic ruler being twisted in opposite directions is an example of what kind of force, grade 7? Torsion. Yay! And last but not least, placing pressure on both ends of a matchstick, causing it to break. It's an example of what kind of failure? Buckle failure. Thank you, grade 7. Hope you enjoyed this little classroom lesson, and I'll see you for your questions next class. Bye.